In this lesson, we're going to look more closely at the difference between classes and objects, and at what is meant by static. We'll use a couple of examples that are in the project Objects Classes to illustrate these ideas. The quick answer to the first question, what's the difference between objects and classes, is that classes are the templates from which objects are created. So, consider a computational model of a customer. Clearly, if you're going to stay in business for long, you need multiple customers, and each needs a record in your computer system so that you can work with it. Each time you say new customer, Java creates a new object in memory. So here you can see we have created 3 individual customers. If it helps, you can think of this like a new structure instance. It's very similar to that. Or as a new row in a database. It's very similar to that too, except we can't search for it and it's in memory, not on disk. So we will expect to create many customer objects while the program is running. Each object will represent a different customer. So for example, one customer is named Fred, while another is named Jim, and the third is named Sheila. But each customer object was built from the same class, called customer. The class is the template that says each object must contain certain variables. So in this example, we see that every customer has a name, an address, and a credit limit. It's the job of the customer class to specify that those fields must exist in every object that is created from this class. Each time that we want to get information about a particular customer, we need to have a handle on that particular customer. That's what our variable names are for. Customer C is a handle on the customer we created with the name of Sheila. That's rather obvious in one sense. If I had a meeting with 1,000 customers showing up and just yelled in the air, "Hey customer, what's your name?" nobody would know if they should answer or not. But if I walk up to one particular customer, shake their hand and say, "Welcome, I'm so glad you could come. What's your name?" I can expect a sensible answer. This is what happens when we prefix a method with a reference to a particular object. So here you see b.getName asks the question getName of the customer referred to by B. Many object-oriented programmers actually like to refer to this type of method invocation as sending a message to the object. Sometimes, however, we don't want to ask a question of a particular object. We want to ask something that is related to the class of objects. Consider, for example, that we are a salesperson wanting to go on a visit to some customers. We wouldn't phone one customer and ask them if there were other clients of ours nearby. Similarly, it would not make sense to code this as a method that would require us to send the message to a particular customer object. We might not even have any reference to any customer in the right area yet. Instead, what we do for our getCustomerNearAddress method that you see here is to label the method as static. And that makes it belong to the customer class rather than the individual objects. It's not something we ask a particular customer about. Notice here, we don't say b.getCustomersNearAddress, we say customer.getCustomerNearAddress. So in this way, we direct the message to the customer class as a whole using this special syntax customer.getCustomersNearAddress. It's important to realize that this is not a trivial method to implement. So you'll see here, we've actually just described the kind of thing that would need to be done. We would probably need the help of a database to achieve this one. In particular, the rest of this class, the way it's written, does not have any means of knowing about all the customers that we have. It's perfectly possible to code a class so that it does know that, but it has not happened here. The other thing that we must be clear about is that in each of these static methods, which are sometimes, by the way, called class methods, there is no this variable. We cannot refer to the fields of the current object, which is what this refers to, because there is no current object. We didn't direct this request to any particular object, so the compiler couldn't know what we meant if we referred to this.name, for example. Let's look at another example that works with a class called date. Each object of the date class represents a particular point on a calendar. You can see here we have a day, a month, and a year within this date. Consequently, most of the methods are not labeled as static. They must be invoked on a particular date object to work. So we have the getDay method, which will return the day in the particular date that this method was invoked on. We could just as well say this.day, and that means the same thing in this case. It's often a shorthand just to leave the this off and describe it in slightly briefer terms. But two of these methods are asking questions about things related to calendars, but not about a specific date object. Here, asking if a particular year is a leap year doesn't require a whole date, just a year. Asking how many days in a month there are doesn't require a particular date either, just a month and year that we're interested in. So we can mark these methods as static and invoke them in the context of a date class as a whole, rather than asking a particular date about something that is more general than that particular date itself. Notice what happens though if we try to change the reference to year to this.year. We get an error. The error says non-static variable this cannot be referenced from a static context. The compiler is making this complaint because there's no current this available, so it can't resolve this.year into anything meaningful. In addition to static methods, we can have static variables. In this case, you create one variable that will be related to the class as a whole, rather than getting a new variable every time you create a new object. An example of a static variable would be the maximum design speed of a particular type of car. Every Ferrari Testarossa, for example, has its own color, physical location, current speed, and amount of fuel in the tank. But the maximum design speed is 180 miles per hour. That's shared by all of them, and that would be a fair candidate for being a static variable. We could also use a static variable to keep account of the number of customer objects created. So here you see private static int count equals 0. Notice in this example how the count variable is incremented in the constructor. There is our public customer constructor. It may also be accessed by the static method getCustomerCount. There we say return count. Even though the static method can't use this to identify an element like the name or address, because we don't know which customer we're talking about, we can access static variables because they, like the static method, belong to the class, so we don't need this to find them. It's an interesting design decision as to whether a method or variable should be static or not. Generally, consider that if the method is operating on an object, or if the data are specific to the instance of the object, then whatever it is should not be static. But if it's a method doing general stuff related to the class as a whole, or if it represents data about the class as a whole, then it should be static. By the way, too many static items showing up in a program suggests that whoever wrote the code hasn't necessarily grasped the whole OO design thing very well yet. So, to wrap up, this lesson has considered the difference between objects and the classes that describe them, and investigated the significance of static, or the absence of the static keyword, as applied to methods and variables.